Okay, we want to graph the line y equal negative 1/3 x, and just for a little review, a couple different ways to do this. One is with a table. So let's make a table of values of x and y that satisfy this equation. Then we'll put them on this coordinate system, draw a line through them, that'll be the graph. So I can start by saying, let's let x be equal to 0. So when x is 0, negative 1/3 times x is going to be 0. Now, let's make it convenient for ourselves. So let's start with the next value of x as 3. So I have negative 1/3 times 3. Well, 1/3 times 3 is 1. With the negative sign, then that's negative 1. Let's take one more point. How about negative 3? So if I put in negative 3 for x, I get negative 1/3 times negative 3. That's going to be positive 1. So I'll plot those points. Here's 0, 0. X equal 1, 2, 3, y equal negative 1, and x equal negative 3, 1, 2, 3 in that direction, and then up 1. So when I draw a line through those points right there, that's where I get the graph of y equal negative 1/3 x. So another way to do it, if you recall, we have this slope-intercept form of the equation of a straight line. So if I look at my equation and put it in this form, it looks like this. Y equals negative 1/3 x plus, I need a y-intercept. What is it going to be so I don't change the value of this equation? 0. So when I look at it that way, I can say, okay, this graph crosses the y-axis at 0, so I'll put that in. And then it has a slope of negative 1/3. So if I go back, if I go down 1, I've got to go forward 3 to get back to the graph, or if I go up 1, I've got to go back 3 to get to the graph. Whatever that ratio is, remember that this is the change in y divided by the change in x, and it has to come out to be negative 1/3. So it could be negative 1 over 3, it could be 1 over negative 3, it could be negative 2 over 6, whatever it is, but the top is the vertical change, the bottom is the horizontal change. So if I was to go back 2 vertically, 1, 2, then I'd have to go forward 6 to get back to the graph, and that would be that point. However you do it, that ratio of change in y to change in x has to come out to be negative 1/3. So just a little reminder here, what we're doing here when we graph an equation like this on a coordinate system, we're doing what's called analytic geometry. And usually the people that get credit for inventing that, because it was a big deal in the history of mathematics, are the French philosopher and mathematician Descartes, and also the Persian poet and mathematician Omar Khayyam. So just a little bit of history in there with that. But here's a little review of graphing straight lines. Table, or in this case, the slope-intercept form of the equation of the line.